1. How polar vortex patterns create winter cold snaps. 2. The polar vortex shift, winter weather's new frontier. 3. Unmasking the polar vortex, why America's winters are getting weirder. 1. How polar vortex patterns create winter cold snaps. Picture this: a colossal swirl of bone-chilling air high in the Arctic stratosphere that's normally locked away, but when it starts to wobble, it can unleash brutal cold waves that make your winter feel like an Arctic nightmare, and that's exactly what's been puzzling scientists amid our warming planet. This phenomenon isn't just random, it's tied to specific patterns in something called the polar vortex, and understanding them could change how we prepare for extreme weather. But before we dive in, let's break it down simply because, trust me, even if you're new to this, you'll get it without feeling overwhelmed. Now, the polar vortex is like a giant, invisible river of supercold air that circles the North Pole in the stratosphere, which is the layer of the atmosphere way above where planes fly. Think of it as nature's freezer lid, keeping that frigid air contained and out of our way most of the time. Temperatures up there rarely climb above freezing, and in the Arctic, it's even colder. We're talking minus 70 degrees Fahrenheit or lower, stuff we'd never deal with on the ground. Usually, this vortex behaves itself, acting as a barrier so we don't get blasted by that cold. But when things go haywire, it can spill out and cause those shocking cold snaps that grab headlines. Scientists have long suspected that disruptions in this vortex are behind some of the toughest winter chills, especially in places like North America. A fresh study by researchers, including Dr. Lori Agel from the University of Massachusetts Lowell, has pinpointed not just one, but two key ways this happens, expanding on what we knew before. First off, there's the familiar story of sudden stratospheric warmings, or SSWs. These are events where warm air from lower in the atmosphere gets pushed up high, messing with the vortex and sometimes splitting it or shifting it southward. That can send a rush of cold air barreling down to mid-latitude areas, like the central U.S., turning a mild winter day into a deep freeze overnight. But here's where it gets controversial, and this is the part most people miss: it's not always about these warmings. The study uncovered another trigger where the vortex itself stretches out like a rubber band, extending from eastern Asia all the way to western North America. They call this pattern P2, and it's a bit like the vortex getting elongated and weakened, which allows cold air to slip southward toward western Canada and the northwestern U.S. Then there's P3, which involves mismatches in the shape and strength between the upper and lower parts of the vortex. When that happens, it can displace the whole thing toward the North Atlantic or western Canada, pushing cold air over central and eastern parts of North America instead. For example, imagine a scenario where a stretched vortex lets loose a blast of cold that hits Seattle hard, while a mismatched one might leave Chicago buried under snow. It's all about the direction and intensity of these shifts. As that cold air moves and spreads out, driven by the prevailing westerly winds, it often loses some of its edge but still causes widespread chills. Take the infamous Texas freeze in 2021 as a prime example. It wasn't just a fluke, it stemmed from one of these vortex disruptions up north, leading to blackouts, burst pipes, and billions in damages. That event really highlighted how these cold snaps can catch us off guard, especially in regions not used to such extremes. Now, shifting gears a bit, it's no secret that some folks use any cold spell to question climate change, even though global warming is a clear, long-term trend. These events might feel shocking against a backdrop of rising temperatures, but they're often part of natural variability. Or are they? The study shows that over the last decade, the most intense winter deviations have moved westward, with places west of the Mississippi now seeing more extreme cold than before. The researchers aren't sure if this is a lasting change or just a blip tied to cycles like El Niño and La Niña, which are natural climate patterns that influence weather worldwide. El Niño, for instance, can warm the Pacific and alter wind patterns, potentially making the vortex more unstable, while La Niña might cool things down and amplify cold outbreaks. And this is where opinions start to divide. Could the loss of Arctic sea ice, a direct result of global warming, be making the vortex more erratic? Some experts think so, suggesting that as the ice melts, it changes how heat is exchanged in the Arctic, leading to more frequent and severe cold snaps in certain areas. But not everyone agrees on the strength of this link, and that's a debate worth exploring. Despite the polar vortex being an ancient feature of our planet's atmosphere, with disruptions likely happening for centuries, the study found that pattern P2 has become more common lately. In fact, winters in the northwestern U.S. have actually gotten colder since 2015, even as overall annual temperatures keep climbing globally. It's a reminder that climate change isn't just about uniform heating. It can create weird, counterintuitive effects, like making some spots chillier in winter while the planet as a whole warms up. The researchers put it well: climate shifts can bring more unpredictable and sometimes baffling weather patterns that challenge our expectations. The upside? By unraveling these vortex behaviors, we can get better at predicting when a cold snap is coming. That means more time for people, cities, and power grids to prepare. Think stocking up on supplies or reinforcing infrastructure against the cold. And with the study published openly in Science Advances, it's all there for anyone to dig into. But let's not wrap this up without stirring the pot a little. If these cold events are becoming more tied to a changing climate, does that mean we're in for more surprises, or is it all just part of the natural ebb and flow? What do you think? Should we be worried about these vortex patterns intensifying, or is it overblown? Drop your thoughts in the comments. I'd love to hear if you agree or have a different take on how this fits into the bigger picture of our warming world. 2. The polar vortex shift, winter weather's new frontier. Brace yourself, winter's worst is moving west. Imagine the worst winter weather you've ever experienced. Now, imagine it happening not on the East Coast, but in the Pacific Northwest and Northern Rockies. A groundbreaking study spanning over 4 decades has uncovered a dramatic shift in severe winter storms, and it's not what you'd expect. The polar vortex, that massive, spinning ring of cold air high above the Arctic, is changing its behavior, and communities from Montana to Washington may need to brace for more frequent extreme cold, heavy snow, and power grid strain. But here's where it gets controversial. The polar vortex, that atmospheric giant, determines which parts of America get pummeled by winter's worst conditions. When it wobbles westward, states like Montana, Idaho, and Washington bear the brunt of winter fury. When it shifts eastward, areas from the Great Lakes down to the southeast get hammered instead. But why is this happening? And what does it mean for communities that have never had to deal with such extreme winter weather? Scientists analyzed 42 years of weather data and discovered 2 distinct polar vortex patterns that each deliver misery to different regions. Since 2015, one pattern has become dramatically more common, explaining why places like Montana and Washington are seeing more severe winter weather while traditional East Coast snow zones experience somewhat less. The mechanism involves atmospheric waves that bounce between the upper atmosphere and ground level, amplifying weather patterns and making them more extreme. Scientists call this stratospheric wave reflection, which is essentially nature's way of turning up the volume on winter weather. And this is the part most people miss. Since 2015, severe winter conditions have been migrating northwestward across the country. The research shows a northwestward shift in severe winter weather across the U.S. is concurrent with an increase in the frequency of the westward-focused variation relative to the eastward-focused variation. Communities in the Pacific Northwest and Northern Rockies that historically dealt with milder winters now face more frequent extreme conditions. Meanwhile, areas that typically prepared for brutal winters, from New England down through the Mid-Atlantic, are seeing their severe weather expectations shift. The study notes that recent U.S. cold extremes occurred in the winters of 2009/2010, 2013/2014, 2014/2015, 2020/2021, and 2024/2025, demonstrating these new patterns in action across different regions. But here's where it gets even more interesting. The research uncovered a connection between these shifting patterns and La Nina cycles, periods when Pacific Ocean temperatures drop below normal. The western-focused pattern that brings severe weather to the northwestern U.S. occurs more often during La Nina conditions. Since 2000, La Nina events have become more frequent, potentially explaining why northwestern states are experiencing more severe winter weather. The study found that 64.3% of the January to February 2008 to 2021 oceanic Niño index values were negative during this period, indicating La Niña-like conditions. Pacific Ocean temperature changes create ripple effects throughout global weather patterns, influencing how the polar vortex behaves and where it sends its worst weather. Rather than just measuring temperature drops, scientists examined comprehensive winter severity using an index that combines temperature, snowfall, and snow depth. This approach captures the full impact of winter weather events that shut down cities, strain power grids, and create dangerous conditions for millions. The northwestern pattern particularly excels at producing severe snowfall, while the central eastern pattern delivers both extreme cold and heavy snow. These differences matter enormously for emergency preparedness, infrastructure planning, and energy grid management. Despite overall warming trends from climate change, the study notes that episodes of extreme winter cold and snow continue to occur in many of these mid-latitude regions. Winter weather events continue occurring with similar intensity, they're just happening in different places. Communities in the Pacific Northwest and Northern Rockies may need to invest more heavily in winter weather infrastructure, while traditional snow belt regions should remain vigilant as the eastern pattern still occurs regularly. The polar vortex's wandering behavior reshapes where winter hits hardest, demanding new approaches to preparation that match atmospheric realities. As these patterns continue evolving, Americans from Seattle to Syracuse need awareness of how shifting polar vortex behavior affects their winter weather expectations. But what do you think? Is this shift in winter weather patterns a cause for concern, or just a natural part of our changing climate? Do you think communities in the Pacific Northwest and Northern Rockies are prepared for the increased severity of winter weather? Share your thoughts in the comments below and let's spark a discussion. Disclaimer: this article summarizes findings from cold air outbreaks in the continental U.S., connections with stratospheric variations, Agel et al., Science Advances, 2025. The study describes statistical trends in weather patterns over 4 decades. It does not predict specific future storms. Readers should always consult local weather forecasts and official emergency guidance when preparing for winter weather. Paper summary. Methodology. Researchers analyzed 42 years of winter weather data, 1980 to 2021, from NASA's MERA-2 reanalysis, focusing on January and February conditions. They used K-means clustering techniques to identify 5 distinct patterns of polar vortex behavior by examining geopotential height anomalies at 2 atmospheric levels, 10 HPA and 100 HPA, over the northern polar cap. The study incorporated multiple weather variables including temperature, snowfall, snow depth, and atmospheric wave patterns, and used the reanalysis-based Accumulated Winter Season Severity Index, RAWSSI, to measure winter weather severity across different U.S. regions. Results. The analysis identified 5 polar vortex patterns, with 2 specifically linked to severe U.S. winter weather, one bringing extreme conditions to the northwestern U.S. and another affecting the central eastern U.S. Since 2015, there has been a significant northwestward shift in severe winter weather patterns, with the northwestern-focused pattern becoming more frequent relative to the eastern-focused pattern. The study found strong connections between these patterns and El Niño/La Niña cycles, with La Niña conditions favoring the northwestern pattern. Both patterns involve stratospheric wave reflection, but occur at different times relative to weather events. Limitations. The study's 42-year timeframe, 1980 to 2021, may not be sufficient to fully understand relationships with decadal climate features like the Pacific Decadal Oscillation. The relationship between El Niño/Southern Oscillation and polar vortex states has been shown to be weak over this time period and might involve complex nonlinear relationships that require longer datasets to fully understand. Funding and disclosures. This research was supported by multiple National Science Foundation grants, National Oceanic and Atmospheric Administration grants, Department of Energy funding, and European Union Horizon 2020 research programs. The authors declared no competing interests. All data needed to evaluate the study's conclusions are available through the paper, supplementary materials, and publicly accessible databases. Publication information. Agel L. Cohen J. Barlow M. Pfeiffer K. Francis J. Garfinkel C. I. and Kretschmer M. 2025. Cold air outbreaks in the continental U.S. Connections with stratospheric variations. Science Advances, 11, EB 9557. DOI, 10.1126/SciAd.ADQ 9557. Published July 11, 2025. About study finds analysis. Called brilliant, fantastic, and spot on by scientists and researchers, our acclaimed study finds analysis articles are created using an exclusive AI-based model with complete human oversight by the study finds editorial team. For these articles, we use an unparalleled LLM process across multiple systems to analyze entire journal papers, extract data, and create accurate, accessible content. Our writing and editing team proofreads and polishes each and every article before publishing. With recent studies showing that artificial intelligence can interpret scientific research as good as, or even better, than field experts and specialists, Study Finds was among the earliest to adopt and test this technology before approving its widespread use on our site. We stand by our practice and continuously update our processes to ensure the very highest level of accuracy. Read our AI policy for more information. Our editorial team. Steve Fink, Editor-in-Chief. Sophia Naughton, Associate Editor. 3. Unmasking the Polar Vortex. Why America's Winters Are Getting Weirder. Imagine this: even as the planet warms, parts of America can still be gripped by bone-chilling cold. It seems contradictory, doesn't it? But this phenomenon is not just a fluke. It's backed by scientific research that sheds light on the complex relationship between our climate and winter weather patterns. A recent study reveals that two specific behaviors of the polar vortex, a swirling mass of frigid air high in the stratosphere, play a crucial role in directing extreme cold to various regions across the United States. One of these patterns channels Arctic air into the northwest, while the other sends it cascading into the central and eastern parts of the country. Since 2015, the Northwest has seen an uptick in these frigid outbreaks, a change linked to shifts in stratospheric dynamics that are influenced by larger climate cycles. In essence, the conditions high above the Arctic can significantly impact the winter weather we experience right at home. As winters in the U.S. trend warmer on average, it's surprising to note that severe cold snaps still manage to blanket vast areas of the country with unexpected intensity. A new study provides a compelling explanation. The answer may lie more than 10 miles above us, in the evolving patterns of the stratosphere. This international research team includes notable experts such as Professor Chaim Garfinkel from Hebrew University, Dr. Lori Agel and Professor Matthew Barlow from the University of Massachusetts, Professor Judah Cohen from MIT and Atmospheric and Environmental Research, Carl Pfeiffer from Atmospheric and Environmental Research in Hampton, Professor Jennifer Francis from the Woodwell Climate Research Center, and Professor Marlene Kretschmer from the University of Leipzig. Their findings, published in the journal Science Advances, illuminate how two distinct patterns within the polar vortex can trigger severe cold weather events across different regions of the U.S. While the term polar vortex often comes up when winter weather turns harsh, our goal was to delve deeper and comprehend how variations within this vortex influence the timing and location of extreme cold spells. The researchers stated, #2 vortex patterns, 2 outcomes for the U.S. The team identified 2 unique variations of the polar vortex, both associated with what scientists refer to as a stretched vortex. This term describes a distorted and displaced circulation pattern that can lead to unusual weather phenomena on the ground. The first variation shifts the vortex toward western Canada, paving the way for severe cold in the northwestern U.S. The second variation nudges the vortex toward the North Atlantic, unleashing icy air across the central and eastern U.S. Both variations are linked to changes in how atmospheric waves travel around the globe, effectively altering the jet stream and dragging Arctic air much further south than usual. #A westward shift in cold temperatures. One of the most striking revelations from this study is that since 2015, much of the northwestern U.S. has been experiencing colder winters, which stands in stark contrast to the overall warming trend. The researchers attribute this shift to an increase in the frequency of the westward-focused vortex pattern, which also aligns with stronger negative phases of the El Niño/Southern Oscillation, YENISO, a significant global climate driver. Climate change doesn't simply mean that temperatures rise everywhere all the time. It also leads to more intricate, and sometimes counterintuitive shifts in where extreme weather occurs. The researchers explained. ###why this matters. Understanding these findings is crucial, as they help clarify the reasons behind recent cold waves in states like Montana, the Plains, and even Texas, as seen in February 2021, which resulted in significant fatalities and insured losses. Meanwhile, other regions may enjoy milder winters. By grasping the influence of the stratosphere on weather patterns, we can enhance long-range forecasting capabilities, enabling cities, power grids, and agricultural sectors to better prepare for winter extremes, even as the overall climate continues to warm. This important research was made possible through funding from a U.S. NSF/BSF grant, led by Chaim Garfinkel of Hebrew University and Judah Cohen of Atmospheric and Environmental Research and MIT.